All right, so we are going to be moving into section 3.2 now. And so we're still going to be talking about functions, but in these next couple of videos for this section, we're going to be looking at functions graphs and talking about some of the necessary properties that will help us be successful when it comes to functions. And so before we get into the actual graphing part, I do want to do a little bit of a refresher problem we did back in chapter 1, just so you're aware of how we still do it now. So back in chapter 1, we talked about how to find the x and y intercepts of a equation. And so we're going to be seeing that again in this chapter as well. But what I do want you to be aware of is there is a different word that might show up now, and that means it says find the zeros. Whenever you are asked to find the zeros of a function, it's asking you to find the x-intercepts, and then there is no fancy word for this. It'll ask you to find the y-intercept. So what you might remember from previous sections is beginning with the x-intercept. Anytime you are asked to find the x-intercepts of a graph, you have to let y equal 0 traditionally. Now you'll notice there is no y in this problem as you see, but what we should also note here is that instead of y in chapter 3, we're going to be using f of x. So when it says do an x-intercept, we're just going to let our f of x or our y value be 0 here. And so that will give us 0 equals x squared minus x minus 6. Now, also from chapter 1, when we solved quadratic equations like this, we would usually factor them. And so we want to factor this quadratic equation. So I need two numbers that multiply to get -6 and add to get -1. So that should be -3 and +2. And then remember, after you factor, you set both of them equal to 0. So x minus 3 equals 0, x plus 2 equals 0, and we will solve them individually. On the first one, we will add 3 to both sides to get x equals 3. And on the second one, we will subtract 2 from both sides to get x equals -2. And so on your homework, if they just ask for the numbers, you can type those in or pick those on your answer choice. If they do want them as an ordered pair, remember your y value is 0 on both of these. So your ordered pairs would be 3, 0 and -2, 0. Now we also need the y-intercept. So remember from chapter 1, when you go to find a y-intercept, you're going to let x equal 0. So instead of f of x, we're going to call this y. And then you're going to have 0 squared minus 0 minus 6. And if you simplify that, not much to do there. You should just end up with a -6 on the right. So if it just wants the numbers or the number, your answer would be -6. But if you have to write this as an ordered pair, remember your x value is 0 and your y value would be -6. And so this has a little bit of a refresher there. Remember, you have to be able to find x and y intercepts of a function as well, but they're done the exact same way as they were in chapter 1. All right. Earlier in chapter 3, so in section 3.1, we talked about domain and range of a relation. Now we want to look at domain and range of a graph. So remember from the last section, whenever you want to find the domain of a function, you are looking at the x values of your graph. And anytime you want to find the range, you are focused on the y values. So how do we do this from a graph? And so here's kind of my way of teaching this. Let's begin with the first graph. Once again, if you need to pause the video to draw the graph before I go over it, do that, but I'm just going to go ahead and jump straight into this. Whenever I want to find the domain of a graph, I know that domain is x values from my definition. So what I usually do is I know that the x-axis runs left and right, and so I ask myself, what's the furthest left this graph goes? That would be at -5. And what's the furthest right the graph goes? That would be at x equals 3. That gives me my left and right point of the interval that I have to draw for my domain. Now, as we know about interval notation, you either have to put a parentheses or a bracket on this, and how you do that is by the circles on the graph. Remember, when you can see a closed circle at your point, we will put brackets. And if you see open circles, that's when you would do parentheses, which we'll see in just a second. Similarly, I can find the range the exact same way, except for range, we have to focus on the y values. So I ask myself, if my y-axis is running up and down, for the smallest y value, I have to look how far down does this graph go? Well, notice the lowest point there happens at y equals 0. So remember, you have to use the y value at that point. Don't look at the x number. So that's why I'm getting the 0 from. And then if I look for the highest point, it is up here, but don't use the -5. The highest y value would be 4. Once again, both of those points have a closed dot or a closed circle, so we will once again use brackets to write our answer. And that's how you can pull domain and range from a graph pretty easily. Let's do it again for one that maybe is not as traditional. So number 3, find the domain and range of this graph. Well, once again, to find domain, I'm going to focus on the x values. Now, in this case, the left endpoint is pretty easy here. If I look, the furthest left this graph goes is right here at this open circle, which has an x value of -4. Now, going to the right, here's where it's a little tricky because you see that this graph has an arrow on it and it's going in an upward direction. That's because if you look at this little dotted line right here, this is what's called an asymptote, and we're going to talk more about those later. But essentially, for this dotted line, your graph is not allowed to cross it. It's allowed to get really, really close to it, but it can never cross that dotted line. And since that dotted line occurs at 5, as you can see right here, that is as far to the right as my graph can go. Now on the -4, it's pretty easy to see there's an open circle, so I will use a parentheses there. And since I cannot actually cross the dotted line, I can only get really close to it. Since I can't actually plot a dot at 5, similarly, I have to use a parentheses in order to do that because of the dotted line and not seeing a closed circle. Similarly, let's do the range one more time. So now I'm focused on y values. So I'm looking for the lowest point on the graph, which happens to be the same as the left point, but I'm going to approach it from a y value standpoint. The y value there is -3. And then once again, back to that arrow, since this graph is going up forever, there's no restriction on how high the graph can go, just how far to the right it can go. Since there's no restriction on how high it can go all the way up to infinity. Now, as we've learned in previous section, infinities always get parentheses on them, all right? And on the -3, since there is an open circle, I will also put a parentheses on that as well. And that is the domain and range of the graph on number 3. So as we move down, the second kind of property is kind of the new property. We want to talk about increasing, decreasing, and constant. All right. So if you go look at this graph, look at this picture down here, you'll notice that sometimes as you look at a graph, it is either going in a downward direction, it could be going in an upward direction, or it could be flat. All three of those have a specific name that we have to be comfortable with. So number 1 is the rule for increasing. So if you look down here on our picture, we would say the function is increasing on the interval c to d. So if you look at this piece right here, that would be a section of the graph that is increasing because as you go from left to right, it is going in an upward direction. So if your graph is going up, we say it increases. Versus on this exact same graph, we would say the function is decreasing on the interval a to b. So right here, this would be our interval of decreasing. It's decreasing because between the values of a and b, the graph is going in a downward direction. So if you're going down from left to right, we call that decreasing. And then finally, maybe one you didn't recognize is that we can also say that a graph or a function is constant. And so a graph or a function would be constant. in this case between B and C, if it's flat. So it's not going in an upward direction, it's not going in a downward direction, it's just flat across, looks like a horizontal line. We would call that a constant segment. Now that we know how to identify them from the graph, the question is, how do you express your answer? So a couple of things over here on the right I want to make sure you note. Number one, when you're talking about increasing, decreasing, and constant, number one, you only use the x value in your intervals. You'll notice that on my graph, I only labeled the x-axis on my picture because the y values don't matter when it comes to writing these answers. Number two, you only use parentheses or parentheses in your intervals. This is not the same thing as domain and range. We don't care about the closed circles here. With increasing, decreasing, and constant, all you have to do is always put parentheses on your endpoints. And then the other part is make sure you separate the intervals with a comma, not the union symbol. So in your homework, typically we use a union symbol if you want to write multiple answers, but with increasing, decreasing, and constant, they want you to just put a comma between all your answers. And I'll show you that in just a minute when we do our examples in this video. So now that we have that down, let's take a look at this picture and let's see if we can identify the three parts we just discussed. So from this picture, I'd like you to find the interval of increasing, decreasing, and where is it constant. So let's start with increasing here. All right. So increasing is just asking where is it going in an upward direction. And I'm going to try my best to shade this in if I can. I noticed that starting here to here. So in that little section of the graph, it is increasing, going in an upward direction. So boom, 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 boom. So if that is my one section where the graph is going up, I have to write that as an interval. So remember, you only look at the x values between those two dots. So this one has an x value of -3. This one has an x value of 0. So my interval would be from -3 to 0. And remember, we don't use brackets here. We just use parentheses in this property. All right. For decreasing, where's the graph going in a downward direction? Well, it looks like everything over here, this is obviously going in a downward direction, but also starting here from left to right. Sorry. Wrong button. There we go. Also from here to here, it is going in a downward direction. So since it's going downward in two different spots, we have to write both of these intervals as our answer. So in the first section in purple on the far left, you can tell that we don't know where it starts because the graph is decreasing all the way from the beginning. So we would assume that it starts at -infinity. It stops decreasing at the same point that it started to increase a minute ago, which would be -3. So that would be my first interval. In my second section, it starts to decrease again at this point that has an x value of 4, but we can't see where it stops decreasing, so we assume that it stops at +infinity. Once again, they get parentheses, and here's the difference. In increasing and decreasing, you don't use a union symbol on the homework, and it's going to say that they want you to use a comma instead because you're listing the two intervals of where this would be decreasing. And finally, it asks where is it constant? So you're looking for where on the graph is it straight across. So here in this middle section, starting here to here, your graph is not going up or down, it's flat. So that would be our interval of constant. So this interval of constant starts at 0 and it stops here at 4, with once again us using parentheses as our only notation. And so that is how you can find your intervals of increasing, decreasing, and constant from a graph. All right. And one of the last property, or sorry, next to last properties I want to go over is the idea of relative max or relative min. So we're not going to go too much into this now. I kind of just want to talk about it and then we'll look at it a little bit more in the next video. But essentially what we can see here is that if we are going in, if we're looking for what's called a relative max, let's go over that one first. So a relative maximum will occur if the following happens. If you have a graph, and you can see it here on the right, if your graph changes from increasing to decreasing at a certain point, we call that point a relative maximum. So as you can see in the picture over here, we're going up, we're going up, we're going up, and then at this particular point, we start to go back down. Anytime you change from increasing to decreasing, you will have what's called a relative maximum. And then if you think backwards from this, we also have the idea of what's called a relative minimum. So anytime you have a graph that changes from decreasing to increasing at a certain point, we say that the graph has a relative minimum at that point. So if the graph is going down, 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 and then at a certain point, it starts to go back up, all right, that would be your point of relative minimum, right? So at that point, you would have a relative min. When you're going from decreasing to increasing, remember, if you're going from increasing to decreasing, you would have a relative maximum. All right, and my last property I want to go over here is the idea if a graph is even or odd or neither. So there's two kinds of symmetry that we're going to see here. The first one I want to go over is a little bit easier, and it's called the symmetry of an even function. And so what an even function is that if your graph is divided perfectly around the y-axis, we call this an even function. And so how I usually tell students here is that if you draw a line straight down the middle of your axis, so the y-axis, what should happen is you should see a mirrored image on both sides. If you think of your graph as being a piece of paper, if you were to fold your paper across the y-axis, so folding it vertically, the two graphs would lay on top of each other. That's an example of even. So you have the exact same picture on both sides symmetrically around the y-axis. Little bit trickier is when you have an odd function. So an odd function actually has symmetry around the origin. And so as you can see in my first picture where the two dots were identical from each other, what happens on an odd function is that it's symmetric around this origin right here. So a little bit different here. Now I like to teach this kind of like paper folding a little bit. Instead of doing just the y-axis, what I like to think of it is like the x and the y. And so what happens is if you imagine your graph is a piece of paper, if you were to fold it twice, if you were to fold it with the y-axis, like we did with even, and then fold it with the x, so you would fold it one way this way, then you would fold it this way, your graph should fall on top of each other. So if you can fold your paper like into four pieces, so a fourths, and they are on top of each other, that would be an example of odd. Now, another thing I usually tell people is that typically with odd functions, you're focused on the upper right quadrant and the lower left quadrant. Usually you'll see your imagery between those two, which will help you guide yourself towards it being odd. Odd takes a little bit of practice if you're not used to looking for it, but I've put a number of examples on your homework so you can practice looking for the difference between even and odd. And so to wrap this video up, I want to do an example of each one so we know what we're looking for. So looking at these seven graphs down here, or sorry, these three graphs down here, one of them is an even graph, one of them is an odd graph, and one of them is neither. And I want to make sure we can identify each one. So I'm going to begin by figuring out which of these is the even graph. And so remember, even means you want to be able to look for symmetry around the x-axis. So if you were to, and I'm going to do it for all three of these, if I were to draw a vertical line straight down the y-axis, what I'm asking myself is if I take the piece of paper of all three of these and I just fold it in half once, which of these would be the exact same picture on both sides? And if I do that, only one of them matches perfectly, and it is number 9. That means this must be the picture of an even function. Now I'm going to move to, of the remaining two, which one is your odd function? So if you can't notice it, now that I've already got the even one out of the way, the next thing I'm going to do is add my line across the x-axis. And what you're going to imagine is if you take this piece of paper and you fold it in half and then fold it in half again, which one would have the picture fall on top of it? And so if you look at for which one is symmetric around both folds, it would be number 8. This is an example of an odd function. The other giveaway is that these two pictures are in these bottom right and lower left quadrants. That kind of helps with the idea of odd. Now on this first one, there's not any symmetry on the first fold. There's not any symmetry on the second fold. So therefore, there are times that your graphs will not have symmetry. And this is an example of no symmetry at all. Or I think in your homework, they say just pick neither. And so that is the first half of our properties of functions graphs. In the next video, we're going to look at a few more properties and kind of go over and refresh our memory on some of these. And then we'll start combining questions into one so that you're looking for everything at one time. And we'll do that in the very next video.